Hey everyone, I'm Bort Bortley. Welcome to the Useless Stuff Shop. Today's project is modifying a 3D printer for liquid cooling. Converting a 3D printer to liquid cooling means replacing the Hotend cooling fan and heatsink with a liquid cooling system. So this would be comprised of a heat exchanger at the hot end, a pump and a reservoir, and another heat exchanger with a fan to dissipate the heat at the other end. So it also needs a bunch of plumbing, electrical work, a power supply, quite a bit of fabrication. So to do this project, this printer has an E3D V6 Volcano hot end. We have an extra heatsink to do some modification without taking the printer offline. Some 6063 aluminum tubing, 22 millimeter outside diameter, 19 millimeter inside diameter to make a new cooling jacket. We have a donor cooling jacket from an RC boat motor cooling system. I won't use the cooling jacket on this because it's the wrong size, but it has two neat little fittings with hose barbs that will be just perfect. To attach all of that together, I have some PC Super Epoxy and mixing tips. On the fluid side, we have pump and reservoir with a 12 volt motor, another heat exchanger. This thing just really looks like a radiator right out of a car. Also with a 12 volt fan on it. And these came in a kit from Matter Hackers, the liquid cooling kit. These are literally the same parts that you can buy on eBay and Amazon for much less than what I paid for the kit. But the cool thing about buying from Matter Hackers is they have really great support. So if I have any trouble with these things down the road, I have somebody reliable to go to. So I went ahead and sprang for it. This kit comes with mounting hardware for the reservoir and the pump, some tubing, a couple of different sizes of silicone tubing, some extra cable bits for power, and some nifty little fittings to adapt from one tubing size to the other. I won't be using a lot of the plumbing, especially this smaller tubing, because I have some other ideas for where I want to take it in the future. I got some of my own tubing. This is 8 millimeter silicone tubing. And most of the rest of this stuff came from Amazon. It's fairly inexpensive. Oh, got a couple of, these are bulkhead hose barb fittings. These will be what I'll use to pass the plumbing through the printer's enclosure. We have the coolant itself. This is PC Ice, low conductive performance fluid in blood red. That should be interesting. And the power supply that powers this is from Schnitt Power. So I'm expecting this to be the Schnitt, frankly. A little brick supply. I will mount this to the 2020 rail frame that encloses the printer. So one of the first tasks will be to create mounting for this. I've printed a mounting bracket for the heat exchanger. So it'll bolt right in like that. This will also mount to the 2020 rail frame. And an adapter for the modified heatsink with the cooling jacket that I'd like to use. So the last part to be printed is the mounting for this power supply. So let's get started on that. while the power supply mount is printing, we'll get started on the next part, which is modifying the hot end, adding a water cooling jacket. So we'll start with a new E3D V6 heatsink, and I'll turn it down so that I can slip a piece of this aluminum tubing over it. So the tubing I'll cut to length, and I have these fittings from this water cooling jacket from an RC boat motor that I will harvest. We'll see how this goes here. Hopefully I won't break anything. They are not only threaded in, but also epoxied, so I could be just stripping the threads out right now. Nope, success. Alright, that's one. Alright, 2 for 2. The way that this will work is I'll pull out the Bowden tube connector here and selectively turn down some of these heatsink fins. I'll leave this fin second from the top at near its original length, this middle fin near its original length, and second from the bottom near its original length. The very bottom fin I'll leave at its original length so that the tube, when it slides over, will have something to stop and glue up against. These other fins that remain at near their original diameter will be to keep the tube centered. The rest of these I'll turn down to 14 millimeters. This center fin will also be filed flat right here, and I'll explain why that is in a little bit. It has to do with directing the fluid flow around the heatsink and through the cooling jacket. So let's make some metal shavings. What do you say? So what I mean when I say something cocky like, hey, let's make some wood shavings, is, hey, let's abuse an old woodworking tool by cutting metal on it with an old file. I don't have all the cool tools, but this will do for now. Yeah, this is going to take a while. could pass for a machined part. Maybe? Maybe not. I don't know. It'll work for this project. Now, as I mentioned before, I need to cut a flat in the middle fin to allow the coolant to move between the lower chamber here where it will come in and the upper chamber where it will exit. So I'll draw a cut line here, and I'm just going to eyeball this because it really is close enough. All it has to be is a passage to let some water through, or is it propylene glycol? And I will use a jeweler's saw to cut that flat. There we go. And now we go to brave field correspondent Bort Bortley for live coverage of aluminum tube cutting. Bort, what is the situation out there? Yes, Bort, I am standing here next to the miter saw, and the situation here is remarkably boring. I will now use said miter saw to cut this piece of aluminum tubing to precisely the right length. Stay tuned. Back to you, Bort. Bravery. Precision. Amazing. That's good reporting. That's all for tonight. Stay safe out there. Okay, now that I got that out of my system, what we have is a turned down heatsink and a water cooling jacket. Actually, 2 water cooling jackets, because I know something you don't know. Neener, neener, neener. And the next step is to drill and tap the water cooling jackets for these 2 hose barb fittings. And I believe that these are M4. Let's find out. So the outside diameter is 3.85 millimeters, and that is pretty consistent with an M4 thread standard. So I will consult the Google. Alright, the Google informs me that the correct drill size is 3.3 millimeters. I don't have exactly that. I've got a 1/8 drill bit, 1/8 inch US measurements. So what I'm going to do is tape this up so that I don't mark it up. I'm going to mark the drill hole locations, tap them with punch them with a center punch, and I'm just going to drill them with a hand drill because frankly I'm tired and too lazy to carry all the camera gear back out to the shop again. Now if I were feeling less lazy, I might take this out to the drill press, but I'm not feeling less lazy. So I'm just going to try and do this here. What I'll do is drill a small pilot hole, because this is 6063 aluminum. It doesn't machine very well. Pilot hole's done. Switch to a larger size drill bit. See if the camera will focus on that. Maybe? There we go. So two 1/8 inch holes, 90-degree offset. Now I'll tap the holes for M4 thread. And these holes at 1/8 inch are about 0.3 millimeter undersized for this tap. So I'll just take it real slow and easy, which is probably good advice for tapping holes in general. Alright, now I have a water cooling jacket with two tapped holes. Just kind of quickly clean these up again. Now the moment of truth. Oh, look at that. That's a beautiful thing. Alright. So I have, ooh, I don't know if I can turn that one quite far enough. Yes, okay. And that one, alright. So this will be the final angles of these two fittings when installed. They come through the inside a little bit, so I will have to see if I can get the coordination to show you that there. I'll have to file those down a little bit because they won't clear the heatsink. But I think that I will do that with a Dremel. Now I'll clean these up a little bit here. Try again. And there's just enough thread left on that. But it'll go in there. And they don't stick through very far. Whatever they do, I'll just clean up with the file. Alright, so now I'm going to Loctite these things in. Probably ought to shake this up first. All right. Now then, in order to ensure the correct coolant flow through this, the heatsink with its flat here needs to be oriented. Let's see if I can get this lined up right. When the cooling jacket is oriented this way, the heatsink with its flat needs to be in this direction so that it is opposite the two fittings. So this will sleeve the two fittings like here. It will sleeve the two fittings like here. Yeah, I gotta file this first. Alright, take two. It will sleeve the heatsink like here, and I will epoxy it together just like this. So I've never used this particular epoxy before. PC Super Epoxy, super strong. It says no sag, no drip. It also says do not subject cured epoxy to heat over 200 Fahrenheit. I don't think that will be a problem for this, as long as the coolant flow is steady. I've also never used one of these mixing tips, but I think that this will be a big help in getting a really nice attractive bead, especially around the top here where it will be visible from the outside. Alright. Cannot use this mixing tip. Awesome. That sucks. The epoxy was $3. Those tips were, I think, about 15. Lameness. Alright, plan B. I have a couple other dispensing syringes laying around, so try mixing this stuff up manually and give that a try. So while the new water-cooled Hotend is curing, we'll go back to the power supply and its mounting bracket. The idea is that the bracket will attach to the printer's enclosure to the 2020 V-slot rail in this channel using some button head screws, M5, and T-slot nuts. So I'll go ahead and start these. And then this will have to be attached in its final position before the power supply is attached. So the power supply attachment as it's planned right now is like this, with cable ties in these grooves going around it to hold it in place. Moving on now to the heat exchanger. This attaches the same way. And this bracket will hold this way so that the airflow is parallel to the side of the you got to be able to see it, don't you? So the heat exchanger will mount in the bracket like this. Bracket will mount on the side of the enclosure like this, the same as with the power supply mount, so that the airflow is parallel to the side of the enclosure. That brings us to the pump and reservoir, which includes this nifty little mounting kit here. Nothing to print on this one, nothing that needs to be fabricated. Just need to decide how to mount it. So these little guys, how do they fit on here? They just, they do, they just snap on. Alright, that's pretty easy. Alright, easiest subassembly of them all. Okay, so now what I think I need to do here, let's run some quick tests on this before we get ready to install it all. Alright, so let's hook this up kind of quick like here and just do a quick power up test to make sure these things actually work. Put this thing in, alright. And then, what do we have here for this little bundle of wires? Okay. Got two cables with latching connectors. Connect to these. And this business. Green power LED, good sign. Moment of truth. Alright. It's on, it's moving air. No suspicious noise. Good. The pump I won't run very long because I don't know if the motor can run dry. So we'll test it just very briefly. It is running, I can hear it, it's blowing funk out. Alright, it works. Nice and quiet, very nice. Alright, test successful. So we can probably start with the installation in the enclosure. So the first thing that I'll work on is trying to finalize mounting locations for the different components. So I've got power supply, heat exchanger, pump and reservoir, and the bulkhead fittings necessary to run the plumbing through the wall of the enclosure. Before I take my printer offline, there's one last test I should do, and that is a quick leak test, because finding a leak now is way less painful than finding one after it's already installed. So, I'm going to start by filling this reservoir just part way with some of the coolant, just enough to get it circulating, get the air out of it, and let the pump build up whatever pressure it's going to. Alright. This is an unexpected result. The pump is running. There we go. Get the air out of it. I need some more. Alright, so I'll just let it run this way for a little bit. See if I see any leaks. I'll come back to it after a while. I'm a little disappointed in the color of the coolant. It sort of just looks like RV antifreeze. Not exactly the blood red that was advertised. Well, at this point, the system has been testing for 4 days continuously because life. But that's not a bad thing. I think I can reasonably conclude at this point that there aren't any leaks. It also serves the purpose of proving the reliability of the pump and the fan motor, which is a good thing also because in doing this modification to the printer, I'm adding multiple new potential points of failure. It's good to get some extra confidence that I won't melt the print head down if a fan fails or something like that. So, on with the show. So, after I said, hey, let's go bolt some stuff onto the printer, I realized, no, there's one more thing. And that one more thing is a bracket that will allow me to mount two tubing reducers, 3/8 to 3/16, so that I can route the plumbing to the print head. So this will mount on the X-axis gantry, 2020 rail, again right here, and I'll just epoxy these guys in. For lack of proper bulkhead connectors, for whatever reason I couldn't find bulkhead connectors in this combination of sizes. Pretty much any other size, but not this size. So I'll make do. Alright, so this will be allowed to dry overnight. Then we can start on the machine.
And now, the moment I have all been waiting for. Hey, I need to talk to you. I may have done something really dumb that could impact our ability to be friends. So, no, I didn't shag your partner. No. But I may or may not have deleted all of the remaining recorded video for the rest of this project. Yeah, maybe. So... So on one hand, that saves me from needing to edit a couple hours of crap video and trying to distill it down into a couple of minutes of useful content, so that's a win. But it leaves me in a little bit of an awkward position about how to restart in a way that isn't super awkward. Like watching my mug on video isn't already awkward enough. But as it turns out, there are some small things that I wanted to change about the design anyway. So I've disassembled those parts that I want to redo, and that puts us back fairly close to where I left off. So to help you catch up to where the project is now, things that are completed that were not completed a moment ago are the installation of the water-cooled Hotend and its plumbing to this bracket, the bracket itself, and a wiring change where I changed to the routing of the wiring back here. Other than that, I think we're in pretty good shape. The biggest change to the design is to the plumbing that comes through the enclosure wall. So previously I brought in plumbing with this hose bar bulkhead fitting that's 3/8 at both ends and ran the 3/8 up the side of the machine. And what I found was that 5/16 tubing, while 5/16 doesn't seem like very much, it was just way too big. It didn't want to route very well. It wanted to kink and get in the way. It caused some unsavory chafing. So I'm changing to this sort of arrangement where I have 3/8 on the outside of the enclosure, 3/16 on the inside at a right angle that'll be directed back this way. This business back here is still pretty ghetto and something I need to do something about because it drags it drags here on the print bed as it moves back and forth.
But that'll be the subject of a future project. For now, I just have it rigged with a little deal to hold it up here out of the way. I have some major rewiring planned for this, and I'll do rerouting of all of this at that time. But for now, I just want to get this big service loop back here to account for the length that the gantry needs to move up and down. Here we are, end of the project. The point of the whole exercise was to improve nylon printing capability. So let's see how it does. Well, here it is. Not too bad. It's not my best nylon print, but it's been a while since I've tried to print nylon. It's been a frustrating experience for me for the most part. And I don't think I started out with the right profile. But to be able to get this on the first shot without having to screw around with it, I'll take it. Not bad for ghetto fab. This is the end of my first project video. What did you think? It was an interesting experience for me. I found that over the course of the project became more about the video than actually modifying the printer, which was really interesting. It caused me to think about the project differently. I had to think about it a little bit in terms of the viewer's perspective and what would make sense to somebody watching it, rather than my usual chaotic way of approaching projects. So that was interesting. It forced me to think about it and plan ahead a little bit, which is kind of cool. I hope you'll join me for the next video. I've already got it planned and have started executing. It should be a good time. I mean, and what could be better than one water-cooled volcano hot end? If you enjoyed it, please like, subscribe, leave me some comments, because I'd like to know if anybody's watching and if anybody cares. If nobody cares, maybe I won't do it anymore after a few. But I'll keep going for now. We'll see what happens. Anyway, thanks. Take it easy.